Classical physics equations fracture when forced to reconcile with quantum wave functions within the same temporal model. Modern physics treats time as a single, one-dimensional scalar quantity, a global parameter denoted as t. This single-time ontology fails outside of narrow macroscopic bounds. It requires ad hoc patches, like measurement postulates in quantum theory, to bridge the gap between deterministic equations and probabilistic reality. The core issue is ontological overcompression, the attempt to force one scalar variable to perform multiple irreducible physical functions. Because our models rely on these external auxiliary principles to make time function, the standard parameterization of time is effectively broken. We propose that time functions as an active set of operators governing the evolution of coherent states. These operators perform active transformations on physical systems, rather than serving as a passive coordinate for movement. The unidirectional flow of time we experience is a secondary effect, a trace left by the asymmetric dominance of these operators across different regimes. We are replacing the geometric intuition of a passive timeline with an operational model, where mathematical transformations act directly upon a structured state. Time acts as a mechanical force that performs physical transformations. Defining time as an action requires first identifying the passive structure it acts upon, space and dimensional layers. This diagram represents the infradimensional scaffolding, a stacked hierarchy of dimensional capacities. Layers like the SU2 interaction layer and hypergravity field provide the structural capacity of reality, remaining strictly passive. These tiers encode where coherence is structured, lacking any intrinsic mechanism to generate evolution. Evolution can only arise through the intervention of an external operational set acting upon this topological capacity. The framework replaces scalar time with 5 irreducible operators acting vertically on this scaffolding. T1 establishes causal sequence. T2 governs recurrence and oscillations. T3 encodes quantum uncertainty. T4 regulates stabilization and classical emergence. T5 enables phase locking across scales. These 5 vectors are ontological primitives. Deriving one from the others leads to circular logic, marking them as the minimal architecture for physical reality. If reality uses 5 operators, we must explain why scalar time succeeds in classical physics. The temporal projection theorem describes classical time as a degenerate projection. In highly stable coherence regimes, the operators for cyclicity, indeterminacy, and resonance are suppressed. This leaves T1, the primary ordering operator, as the sole dominant force, creating the illusion of a single scalar timeline. Under this theorem, relativistic time dilation is reinterpreted as a reduction in operator throughput caused by physical coherence strain. Single-time physics remains a valid model for narrow domains where temporal dynamics collapse into pure ordering. Scalar time becomes pathological in the quantum regime because it cannot account for the active role of indeterminacy. Quantum paradoxes arise when the T1 ordering operator is applied to systems dominated by T3 and T4. We model these interactions using Clifford optima, which naturally accommodates all 5 multivector operators. The commutator interaction between the indeterminacy and coherence operators forms a specific bivector plane. The action within this plane generates a probabilistic to classical torque. In this plane, the stabilization force of T4 acts against the branching states of T3. This mathematical tension drives the transition from a quantum superposition to a definite classical state. By modeling measurement as a continuous transformation within the temporal algebra, we replace ad hoc postulates with a calculable operational event. This algebraic coupling also applies to biology. Living systems utilize a rich commutator plane of cyclicity and resonance to drive rhythmic synchronization. This master equation defines physical evolution as the cumulative interaction between the multivector temporal field and spatial states. Physical evolution is history-sensitive. The metric of reality is path-weighted by the accumulation of irreversible physical records. Space-time acts as a history-sensitive structure, recording the traces of every temporal interaction. Time is relational, cumulative, and directionally structured by 5 interacting vectors. Time is the active, irreducible, and structured transformation of physical coherence itself.